Welcome to this lesson on vectors. Today, we are going to learn a fundamental skill in geometry and physics, how to calculate the magnitude of a vector. Our learning objectives are to understand what magnitude represents, use Pythagoras' theorem to calculate magnitude, and apply the magnitude formula to 2D vectors. By the end of this video, you will be able to determine the length or magnitude of any two-dimensional vector using a simple formula derived from right-angled triangles. Let's start by defining what we actually mean by magnitude. In mathematics, the magnitude of a vector is simply its length. Imagine we have a vector, let's call it v, with components 3 and 4. This means to get from the start of the vector to the end, we move 3 units to the right and 4 units up. When we draw this on a grid, the magnitude is the physical length of that arrow. We represent magnitude using vertical bars, like absolute value symbols, around the vector name. So, whenever you see these bars, the question is asking, how long is this line? To calculate this length, we can turn our vector into a familiar geometric shape. If we draw a horizontal line for the x component and a vertical line for the y component, we form a right-angled triangle. The vector itself is the hypotenuse of this triangle. You might remember Pythagoras' theorem, which states that for any right-angled triangle, a squared plus b squared equals c squared. In our case, a and b are the horizontal and vertical components, and c is the magnitude we want to find. Let's plug in our numbers. 3 squared is 9, and 4 squared is 16. Adding them together gives us 25. To find the length, we take the square root of 25. So, the magnitude of vector v is exactly 5 units. This simple relationship works for every two-dimensional vector. Now, let's generalize this into a formula that you can use every time without needing to draw the triangle. For any vector v with components x and y, written as the magnitude is calculated as the magnitude of v equals the square root of x squared plus y squared. Here are the steps. First, square the x component. Second, square the y component. Third, add the squares together. And finally, take the square root of the result. It is very important to remember that, because we are squaring the components, the magnitude will always be a positive value, even if the components themselves are negative. Length cannot be negative. Let's look at an example. Consider vector u with components -5 and 12. Using our formula, the magnitude of u equals the square root of -5 squared plus 12 squared. -5 squared is 25, and 12 squared is 144. Adding those together gives us the square root of 169. The square root of 169 is 13, so the magnitude of vector u is 13. Sometimes, the magnitude won't be a perfect whole number. In your IGCSE exams, you will often be asked to give your answer to 3 significant figures, or in surd form. Let's try one more example together. Consider the vector w. To find the magnitude of w, we apply our formula. 2 squared is 4, and -3 is +9. Remember, a negative times a negative is always a positive. The sum is 13. Since 13 is not a perfect square, we can leave the answer as the square root of 13, which is the exact surd form. If we put this into a calculator, we get approximately 3.6055. Rounding this to 3 significant figures, we get 3.61. Take a moment to look at the steps we followed. We square, add, and then root. It's a consistent process regardless of the numbers involved. Great work! You have now mastered the basics of calculating the magnitude of a vector. Magnitude is the length of a vector. The formula is the square root of x squared plus y squared. And remember, always square negative components to get a positive result. We have seen how magnitude represents the physical length of a vector arrow, how the formula is directly derived from Pythagoras' theorem, and how to handle both positive and negative components. Before we finish, take a quick moment to think about this vector, -8, -6. How would we find the magnitude of vector A? First, -8 squared is 64. Then, -6 squared is 36. Adding 64 and 36 gives 100. Finally, the square root of 100 is 10. Did you get 10? Keep this formula in your toolkit. The magnitude of vector v equals the square root of x squared plus y squared. It is essential for more advanced vector topics like unit vectors and velocity. Thank you for watching, and keep practicing your calculations.